If you perform the same experiment that is measuring the time period of simple pendulum on the two different planets like Earth and Mercury, then the time period of the pendulum is different on both places. And what thing that affects it, that thing is gravitational field strength. That is the strength of its gravity of planet. So in this question, we will try to find out the time period of pendulum on Mercury if its time period on Earth is T. And T means that the time period is T is equals to 2 pi square root of length of pendulum divided by gravitational field strength, so GE. So we are provided the information that the gravitational field strength on Mercury is zero point 0.4 G, means 40% of what we have on Earth or near the surface of Earth. Not only that, we will try to find it, but also I will explain you why the simple pendulum gets faster or gets slowed down on Mercury in the end of the video. So let's say this is a path of its trajectory, so which it is moving in a circular path, by the way, and this is a equilibrium position where its displacement is zero, as you know that according to the SHM concept, and its time period is 2 pi L over G. Let's find out that what time that it takes to complete one cycle. Means what is one cycle? On Mercury it will go to the other extreme position and then back to its original position. What time does it take? So we know that the time period on the Mercury, let's say Tm, is equals to 2 pi square root of the same length divided by the gravitational field strength on Mercury. Now, we will write here, we will plug the value of the gravitational field strength in terms of the gravitational field strength of Earth, which is zero point 0.4 times GE. And you can write 1 over zero point 0.4 like, why not we can write 10 over 4, or yes, so 10 over 4 L over GE. And then we can take the square root of 10 over 4 outside, and inside what we have remaining is the time period of the pendulum on the Earth, which is described in this question by the letter T. So this square root of 10 over 4 is telling us that the time period of simple pendulum on Mercury is obviously more. So it means that this pendulum will get slow, and I find it. So its exact answer is 1.58. So which we can round off to 1.6 T, and that's why our right answer for this question is option C, which is 1.6 times T. Now, don't go anywhere. I'm going to tell you that why does it slow down in terms of forces. And for this, we must draw, first of all, free body diagram. So this is our rectangular coordinate system. So you know that either it is on the Earth or on a Mercury, there are the two forces, and we can draw them here. So let's say this is a force applied by the Earth. So this is mg. And there's another force that is a force of tension. So this is a force of tension. So if you make a components of mg, so dear students, there are the two components. So the one component is in this direction, and the other component is perpendicular to this. So this is theta, since this is mg cos theta, which is going to cancel or balance with the force of tension, and this is mg sine theta. Now, important thing is this force of mg sine theta is the one that is pulling the object towards the equilibrium position. So now see one thing, I am going to show you a longer arrow for the Earth, because for the Earth that component is more, so mg sine theta. But for the Mercury, that component is smaller, so it is zero point 0.4. So this force, the force that is pulling towards the center, towards the equilibrium position, is less on Mercury. That's why it will get slow, because it is not pulled that harder towards the equilibrium position. So it will complete its cycle, but it will take more time because force pulling towards equilibrium position is small. So I hope you get the idea.